This question says, calculate the solubility at 25 degrees C of CaF2 in pure water and in 0.02 molar sodium fluoride solution. And then it says you'll find the KSP data in the Alex data tab. So basically here we have two problems. The first of which in pure water is just like a previous problem. I think it's two questions earlier on this playlist. And the second problem is with a common ion of the sodium fluoride, which the common ion is F minus. Since this is CaF2, it has fluorine in it, this has fluorine in it, fluoride in it, F minus. So therefore that is the common ion. So essentially this is two separate problems. So let's look at the pure water first, which again is very similar to a previous problem, I think two problems earlier on the playlist. So basically what we have is we have CaF2 solid, which it goes into Ca2 plus aqueous, calcium's a 2A metal, plus 2F minus aqueous. And we have initial change and equilibrium. We ignore this because it's solid. Initially, there's none of these. Then we add x of this and 2x of this, and at equilibrium we have x and 2x. So the KSP, and I'm going through this fairly quickly because, again, it's a very similar problem. The KSP equals the concentration of Ca2 plus times the concentration of F minus squared, plugging in the KSP, which we look up, is 3.45 times 10 to the minus 11. And I'm going to ignore sig figs because I believe the sig figs come out a little bit differently than this. This has for 2 decimal places. So 3.45 times 10 to the minus 11. Ca2 plus is x. F minus is 2x all squared. 2x squared is 2x, then squared is 4x squared, times x is 4x cubed. So essentially what we end up with is 4x cubed equals 3.45 times 10 to the minus 11, divide by 4, and we get x cubed equals 8.625 times 10 to the minus 12. Take the cube root of both sides, and we find that x equals 2.0508 times 10 to the minus 4. And that is moles of Ca2 plus or moles, sorry, I went off the screen there. It's either moles of Ca2 plus or moles of CaF2, which is what I want, moles of CaF2, because they're 1 to 1, per liter. So x is the amount of this that goes into solution, and since this is 1 to 1 with this, it's also the molar solubility of this. But we want grams per liter, so we have to take times the molar mass, which is 78.08 grams of CaF2 per 1 mole of CaF2. And when you do all that math, you find that it's 0.016 grams per liter, and that's grams of CaF2 per liter. So that is how we find the solubility in pure water, which again is 0.016 grams per liter. Now, in the second case, we start with the same equation. The only difference is we have 0.2 molar NaF in solution. So let's look at this again. We have CaF2 solid, and we get Ca2 plus, 2 plus, aqueous, plus 2F minus aqueous. And we can have initial change in equilibrium. Initially, we have no Ca2 plus, but now we have some F minus. It's 0.0200 molar. So this is going to be the F minus in solution. Here, we're going to get x Ca2 plus, we're going to get 2x F minus, and here we get x, and here we get 0.0200 plus 2x. Now, much like we did in previous equilibrium problems, we're going to assume that this x is negligible, or less than 5%. And in the Alex examples that I looked at, it always was, which keeps us from having to FOIL it, and it makes the math easier, and it keeps us from having to use the quadratic equation. So we write the same KSP expression, KSP equals the concentration of Ca2 plus times the concentration of F minus squared. Now, the KSP, which is the same number, 3.45 times 10 to the minus 11 equals Ca2 plus, which is x, and F, we're not going to put in the plus 2x, we're just going to put in 0.0200 squared, and we're going to ignore the x. Now we solve for x, so square this. So 3.45 times 10 to the minus 11 equals x times 4.00 times 10 to the minus 4. Divide by 4 times 10 to the minus 4. Divide by 4 times 10 to the minus 4. And what you find is that x equals 8.625 times 10 to the minus 8. That is, again, the amount of this per liter, and since this is 1-to-1, the amount of this per liter. So it's the moles of CaF2 per liter. Remember that we want it in grams per liter, so we again multiply by the 78.08 grams of CaF2 per 1 mole of CaF2, and we find that it is, to 2 sig figs, 6.7 times 10 to the minus 6 grams per liter. We should also double check that this is less than 5% of this. Well, this is 0.02, this is times 10 to the minus 8, it's way less than 5%, right? This is 10 to the minus 2, this is 10 to the minus 8, it's like a million times smaller, so it's definitely less than 5%. One interesting thing that I want to point out is that this is 6.7 times 10 to the minus 6 grams per liter. So the solubility of CaF2 in pure water is 0.016 grams per liter. Again, still not super soluble. However, in the case of 0.02 molar NaF, which is a source of F minus, a common ion, the solubility is 6.7 times 10 to the minus 6 molar. So this is 4 orders of magnitude smaller. It is much less soluble with a common ion present. And the reason for that is, if there's already F minus in solution, this equilibrium is going to be less likely to shift towards the soluble ions because there's already some F minus present.